Hello, and welcome to this panel discussion about harnessing the power of cobots, as part of our Defining the Smart Manufacturing Journey series sponsored by Rockwell Automation. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the speaker bio window, with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Defining the Smart Manufacturing Journey series. Let's welcome Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look to the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I would like to pass things along to Edgar to lead us through today's discussion on harnessing the power of cobots. Edgar, welcome to today's event.
Thank you, Matt, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology at CSA Group, and I will be moderating this roundtable. Today with us, we have a set of leading experts in Industrial Internet of Things and Industry 4.0 to discuss how collaborative robots and digitalizations are transforming manufacturing. So you're more than welcome to join us with questions and comments in the chat, and we will eventually answer those questions at the end of the roundtable. So today with us, we have Mohsen Sefer. Mohsen is a manager for new product technology at CSA Group, where he develops testing, inspection, and certification programs. He holds a PhD in electrical and computer engineering, as well as an MBA. He has 15 years hands-on experience in advanced technologies in a variety of manufacturing disciplines. We also have with us Dean Phillips, who brings 34 years of manufacturing experience. He's an advisor to SME's Smart Manufacturing Advisory Committee, and he is also an accomplished speaker in IoT, AI, robotics, and AR and VR. He's also an entrepreneur and has served on the board of directors or as an advisor for multiple technical committees. We also have John Soldatos, who owns a PhD in electrical engineering from the University of Athens, and is an honorary research fellow at the Universities of Glasgow and New York. He's an expert in IoT and AI and helped deliver more than 70 smart manufacturing projects in industrial sectors. He has also contributed to more than 200 scientific publications and 7 books in IoT, AI, and cybersecurity topics. And we also have Haytham Mansouri, Business Manager, Servo Motors and Integrated Motion Technologies in Rockwell Automation. Haytham leads Rockwell Automation's global servo motor business, as well as digital technologies, including motion software, simulations, and robotics. He has more than 20 years experience in the field of motion control and industrial automation. He holds a Bachelor of Science degree in Electronic and Automation, as well as a Master of Science and Applied Computer Science from the University of Brussels in Belgium. So John, Dean, Mohsen, and Haytham, thank you very much for being today with us in this roundtable and share your experience and knowledge with our audience. So the next generation of industrial robots is efficient, endlessly adaptable, and approachable to the workers in the factory floor. This is not only changing the work they do, but also how humans value and interact with this new era of industrial robotics. I'm excited to hear what you, the panelists, have to say about this very vital topic. But before we begin, I would like to share, to thanks our series sponsors for today. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell inherited expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything smart in smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So without further delay, let's start with our panel for today. And I would like to start with a very simple question for the benefits of people in our audience that are not too familiar with this topic, who may not know what a collaborative robot is. And that's the question. What is a collaborative robot? What is a cobot?
Edgar, thanks for the question, and thanks for having me today in the panel. I think it makes sense to give the definition of a cobot. A cobot stands for collaborative robot. So it's typically a low-cost industrial robot that is safe to operate in close proximity to human. So this means that in most cases, cobots work together with humans on a task. And this differentiates them from the typical fully autonomous robots that operate autonomously on a task. Also, it means that you have a higher degree of flexibility on a cobot because you have this flexible resource, which is called human, working together with robot. And another big difference is the cost. It's typically lower cost than a fully automatic robotic cell in an industrial environment. Now, if we just want to give a simple example for our audience, I would say that you can imagine a simple robotic cell with a deep neural network doing jointly with a human the quality inspection of a product. So you can imagine that the robotic cell checks the product for quality, but the human sits close to the robot and can intervene to correct it, or even to provide knowledge to the robot and accelerate its knowledge acquisition. Of course, more examples can be found in other industrial tasks like pick and pack or welding and so on.
Thank you, John. Now, I would like to follow on the examples too, because we know about robots. We all have seen those videos of the robotic arms in the manufacturing floor. Well, we also have seen people working on the manufacturing floor. But we would love the audience to kind of visualize what are those applications where robots and humans are working at the same time. So would any of you please give me some examples, like real examples of what applications are robots meant for?
All right, here I can jump in. So the cool thing about cobots is that they're designed to work at human level speed, right? So inherently, they're not very fast. So you find them typically in application where you don't require that much speed. So for example, some pick and place application, as John was mentioning, you have machine tending, for example, if you need to work with CNC machines or injection molding machines where you need to replace tooling or parts of the material. As well as, actually you see them, more and more in inspection, quality control, as John was mentioning, dispensing, gluing, some of the things that don't require super fast and very advanced kind of type of application. But actually, because of the ease of use, ease of integration of the cobot, we see them, taking more and more space within the industrial manufacturing and replacing some of the applications that traditionally have been the domain of just industrial robots in general, like palletizing and this kind of thing. So it's a very exciting area, and I think we're going to see more and more of these cobots kind of taking over a bunch of applications that, they weren't initially meant for, but they're growing into as well.
Thank you, Haitem. Now I'm going to ask the question that some people in the audience may be thinking about, and it's not that technical, but probably more economical and even social. Are we talking that soon these cobots are going to replace workers? Is there any actual reason why workers should be still be on the factory floor?
Yeah, well, I think if I may jump in here, on the contrary, I think cobots are here to guarantee a smoother transition to the era of hyperautomation, because it's actually the human working together with the robot. So the robot or the AI system is a valuable assistant of the human that helps making things, more efficiently, right, and faster, and getting out of putting out of the loop, the tedious part or the repetitive part. I mean, relating to the previous question, which are the tasks that you want to use a cobot for? These are repetitive tasks, tedious tasks, error-prone tasks. That's all good hazardous tasks. So maybe, a task on a hazardous environment. So in all those cases, it's always a good idea to put a robot doing that part of the task, the repetitive, the boring, the error-prone, and then keep the human to do the part that actually requires the human intelligence.
So the judgment is still human, basically.
Yes, it's also as a European, in Europe, the final decision is always human-based, is with human supervision as per the European regulation.
Right. No, that's very interesting. So we can see it more as a human enhancement than a complete separate from humans.
Yeah, and I would even add that we've seen as the growth of robotics is there, that we've seen more labor coming in, not less. So especially as manufacturing is bringing companies are bringing back manufacturing to the US, for example. One of the ways to do that and still remain competitive is by automation. So that automation and robotics allow those manufacturing plants to exist or come back to the US, but obviously they cannot operate on their own. So you need labor to, as John was mentioning. So we see that as enhancing actually the labor market rather than taking away jobs.
Oh, that sounds fantastic. Sorry, go ahead, Ian.
I was going to echo that sentiment, that one of the challenges that you have in a lot of the advanced countries is that you're competing with low-cost labor in other countries. This gives you an opportunity to eliminate some of the problems that we have. I think a lot of people have this perception that it's just the labor cost. That's not it. It's usually also the challenges you have within safety, for example. We're a very litigious society. So if anything happens or goes wrong, especially, let's take, for example, in an industrial application like press brakes, they have 3-to-1 number of injuries. Why? Because people are holding the parts, they're flipping them over. Because they're handling the parts, they're more likely to be cut. They're more likely to have injuries that are related to that, shoulder, back injuries, things that are creating these problems. These cobots, as well as robots in general, can help to alleviate some of that. Sometimes it's heat related, sometimes it's temperature, sometimes the hazard is in an unsafe area. Sometimes you're just working with the cobot who is reaching into an unsafe area that you wouldn't want an operator to put their hands into. It's one thing to lose an end effector off the end of a robot. It's a whole different thing for a human being to lose their hand. So for those reasons, there are opportunities that we have now with cobots to do so much more. And the vision systems are advancing every day. I personally think that this is giving us a new opportunity for those operators to learn new skills. Now they're no longer just an operator. They are now doing the teaching of that cobot. They're setting the range of motion. They are setting the programs, because in general now, most of these cobots are far more advanced at learning without having to have a programmer sit there and write code.
Wow, like themselves, like machine learning kind of thing. Okay, let's part that there, because we're going to approach that a little bit later when we start talking about a little more of the details of the technology itself. But you mentioned something interesting, Dean, and it's about how cobots can increase safety because they avoid the worker to reach an area that can be hazardous for them. However, I can see myself in the shoes of a worker working with a robot. It's a huge piece of machine there besides me. That itself, I feel kind of is a little bit dangerous. So I want to ask Mohsen, from the safety perspective, like from the device itself, Has there been any development on how to approach the machine safety or device safety for when it comes to collaborative robots?
That's an important question, specifically if we are just dividing at the level of the cobots involvement, because that's really get back to the interaction of at what level of interaction the cobots are going to have. Based on the definition that the IFR defined, there's 4 levels. Robots and the human can coexistence, which that's provide a working line so they can work along each other without a fence. So there's going to be a shared workspace. Then there's going to be another condition that's sequential collaboration, means that the human interaction is after the robot, for example, after an inspection, there is another process. The cooperation status, which they are working on the same work or in the same part and with the same time, location, and they are moving as well, which they currently the robots are cooperating in the same environment. And they, at the end, in the responsive collaboration means that the robots can have interaction based on the definition or based on the comments get from human. For all of these scenario, there should be a safety measures. It's depending on the process definition. Currently, a standard environment implemented for the cobots developed through different organizations right now. And ISO developed a standard that later on acquired by the Robotic Industries Association, which all of them using the same standard. The functional safety is the key aspect of the standard that should be considered right now. Standard number RA 1506 is the main, which is the adoption of the ISO 10218-1 and -2, both of them in one document, is the work frame that's defining the step that should be defined. It's coming from the defining the interaction level, the hazardous, the safety aspect of the work, and each step is defining into the make sure that the safety operation and the safety of the users, specifically the human, is also very well addressed in the operation and the usage of technology.
Perfect. Thank you very much, Moses. So, we know that then there are some safety measurements that we have to when we deal with cobots. Now, this seems like a very good technology to have in the factory. Is there any challenge for their implementation that we should be aware of, like probably technology, technical, or even economical?
Well, I think that if you allow me to jump in, there are multifaceted challenges. So one is the technical. I think Dean mentioned that technology is improving every day, but still it's not a perfect technology. So, for example, machine learning or deep learning, you need to have proper data. Then the safety thing needs to be accompanied with proper trust measures, like being able for the human to understand how the robot works. So there are still technical challenges, although the technology is advancing in a very rapid pace. Now, there are certainly social challenges. So usually when I advise clients and I work on projects, we build this up with the workers, involving the unions right from the beginning of a project, so that it is accepted, it is anticipated, no surprise. And so there is a social challenge, and also there is a massive reskilling which will be required for the humans to work together with robots. You can imagine that it's not a matter of doing laborious tasks anymore, but you should be able to look at a screen, to look at a dashboard, to look at some big data and being able to interpret it. So workers, manufacturing workers, industrial workers need new skills. And this is a large-scale reskilling and upskilling project that industrial enterprises need to plan and to execute in the years to come. So this is the social challenge, the people challenge. And then it's a matter of a cultural shift in every company, which should not be underestimated, because it means that the company, from the worker to the business management, should realize a shift and learn to work with data, to work with with robots to work more with automation. And you shouldn't expect this to happen overnight. You have to work on this. And again, it's a matter of working this end-to-end from the worker to the business management, in my opinion.
Adding to John, I would like to highlight about these challenges. Some view that really helping us is the techno-economic analysis is going to give us some more picture on the challenges side. As some items that John mentioned, it's categorized on that. For example, there are some technical variables which is important for consideration. Availability of the technology, the cobot itself. Is it local? Is it from the international market, as John highlighted? Or the expertise, the technical people who needs to deal with this technology is also another challenges can exist there. But beside that, there are some technical aspects like the modification that you need to make in your organization or manufacturing side, which is coming from building facility. You may need to equip new type of equipment like a new power system, site foundation, some of the basics. These are changing the shop floor design because of the safety aspect. These coming from the technical variables. But beside that, at the end, there's another aspect which is economical, because you are going to make some changes based on some, at the end, you want to make money, the business rate of return, something like that. Initial investment, how much money you need to spend on the original technology to acquire the cobots. The investment you need on the modification on the side, and there are so many at the end, how much cost saving you're going to see, and is there any other added value coming from implementing this? For example, you would be able to provide some new services by having those cobots. This techno-economical aspect is going to give us some more view about the challenges as we go, which is dividing on technical aspects highlighted by John, and the economical is also another part.
Thank you. Now, we have discussed already kind of the overview of the technology and how it's impacting society and how companies are using it. So let's now dive in a little bit more in the technology itself. And I want to start with the question, with something that John mentioned a little bit about the skills that people need to learn. And I want to ask those questions to you, and probably Dean, I don't know if I think I have something here in the stuff that we talked before the panel. What are those new skills, or not the skills, but how is that interaction between the cobots and people? Because I mean, the traditional robots, usually you have a program that you send to the robot and the robot does their thing. But when we talk about cobots, how is that interaction happens? How does that interaction happens?
Motion or my
To Dean, sorry. Yeah.
Oh, sorry. Thank you. I think in general, when you start looking at cobots, the nice thing is most of them now have some very simplistic teaching softwares where you can actually move the range of motion within the arm of the cobot. The advantage of that is that not having to write the code of where I'm moving from my origin point to where I need it to stop, I can actually pull it through that motion, teach that. That is a very helpful tool, so that your operators, if they can just learn even the simplest part of it, they can program that range of motion. And that also helps to define the safety range, because part of the whole thing is I don't want it to go further. I don't want it to go out. Many injuries that have happened in the past with robots, first of all, they're heavier, they're bigger, they can do much more damage to a person. But the nice thing is the robots move a little slower. The cobots also, you can limit the range of motion that they're going to. This is when you're working around people, you're going to need that to be the case. You need to have a consistent direction it's moving for, how far I want it to move. Those kinds of things make it a lot easier for an operator to get up to speed. And then they could take ownership. This is my robot. This is my cell. And that really elevates that person to another level. It makes them feel more vested in it. It, in many cases, will lead to other advancements, whether it's in pay or titles within the company. They have a lot of value within just doing those kinds of things in collaborative robots. The other thing, as Moshe had mentioned, he had talked about the cost of ownership of a robot. Some of the companies now are treating it like an employee. You pay them a per hour rate for those robots now. So you're hiring them for today, or you're hiring them for a month, or whatever that period of time is. And that can completely offset that cost of ownership. That's like, boy, I don't know if I want to invest in that robot. Now I can go ahead and rent this robot for the next month, and at an hourly wage that you're paying. So
something like
really
a robot
incredible.
as a service or something like that.
Yes, exactly. Absolutely.
Wow. Now,
and that adds to the flexibility, right? You can bring it in whenever you need it, and you can add if you think that you can do more. You can easily add. Or
just to add to I think Dean gave an excellent example that if you see everybody that sees that in the factory starts loving it, right? Because it's just a human showing to the robot how they have to move the arm, and then the robot takes it from there. In the future, we're gonna see even more interaction modalities. For example, natural language interaction.
Wow.
You'll be able to talk to the robot, right? Like saying, okay, this product is defective, this product is not defective, and the robot will just recognize the text and will update its knowledge base. You're gonna see robots participating, in augmented reality, mixed reality interactions, like an industrial metaverse, and being able, to be taught by seeing, the movement of the human in an augmented reality environment. So, I just want to highlight, the potential, right? Certainly, we start from something today, which are, viewing simple dashboards and visualization. But down the road, we will see much more impressive and efficient things. For example, NLP interaction. For me, it's the basic technology is already here. So I think we will see it soon in the factory.
Wow. Now, what level of autonomy can these devices reach then? Like, would they become at one point fully autonomous?
Well, I think let's make a distinguishing line here, okay? You want them to be autonomous because that's where the return on investment comes from, right? The less human intervention. But on the other hand, we acknowledge that, especially in difficult tasks, they cannot be 100% autonomous. So that's where the human supervision is there, giving data, giving instruction, doing a part of the task, which is more challenging, more dynamic for the robot and can be done. And I think that's the beauty of this cobot interaction, because you actually get the best of both worlds, of the human and of the robot.
Yeah. Now, thank you, John. Now, Haitham, you mentioned, I think at one point before about, I don't know if it was you or Dean that mentioned about this machine learning potential for the robot to improve. So where does it fit, Haitham, in this area in cobots?
Yeah, it is exactly just like John mentioned. So you're going to see some more and more autonomy in the cobots, but they might not be fully autonomous. But I think the evolution is really, instead of telling the cobots or the robot in general, how to do a task, it's simply saying, this is the outcome, the desired outcome, right? And that level of autonomy will come by the robot through AI to figure out how to get that outcome done and improve on it as well. So I think that's where we're going to see, especially when you pair it with a vision sensor, right? And you have different tasks. You don't want to start programming and figure out, if you have different packages, how to pick them up and stuff like that. Is the idea to say, I need these products to be picked up. And then through learning, the robot will be able to figure out the best possible way to pick the different packages and then work from there.
All right. Now, now that I have you here, Haitham, I want to ask you, because probably you're familiar with that. What are those components that are enabling this technology, like compared to the big robots? Like components-wise, what is special about the ones that cobots use?
Yeah, so from a cobot perspective, so we're talking about the safety aspect. I think the safety aspect is fundamental for that. These robots are designed directly with force and speed limitations, so you cannot exceed, those. So that makes it inherently safe from that perspective, right? So I think that's one of the major differences. Other than that, the fundamental core system is a motion system, right? Just like you find in any other robots and coordinated joint movement. So really the difference is about the limitation on the force speed, as well as maybe some of the material that the robot is built, like lighter weight material versus the more industrial products.
Sounds great. Now, additive manufacturing, like we know it is a technique that is being used now when we want to be more accurate in the design and in the manufacturing of devices. How are cobots actually working with additive manufacturing and bringing some advantages to the smart manufacturing floor?
That's a great question. I think right now one of the big challenges that it's solving for people is, how do I pick up a part? How do I do different manipulations of the part? That's if I'm holding it. Now, you may have seen where they have now like the squid or the octopus styles where they reach around something. So here's the object, it comes around and it reaches and wraps around it. So it can control what it's holding, but it doesn't do it with so much force that it crushes it. Those types of systems, and they also incorporate some of them that actually use air, that actually hold it with that, so that as opposed to just a simple end effector where it just closes and opens. So now what you could do is you can build through additive customized end effectors. So I can customize what that is to go around the shape that I have. So nowadays they're already building different custom end effectors so that they close in a different way. They close around a specific shape. That way you get a more customized experience and it fits your part. And you may have things that have crumple zones on them or things that are too soft that you would actually crush when you're holding it, and you don't want that to occur. Additive is a great opportunity to use the tools in additive to pull them into the cobot environment to work as a hand would, or to work as something that, because you think about your hand, it isn't just squeezing something, it's actually has a lot of delicate motions, and being able to carry and lift something with a little bit of force, but not too much that you throw it up in the air when you lift something. So you have to have that control, and the new end effectors that are being built through additive and 3D printing give you new opportunities.
Well, so it's truly a human enhancement tool, the cobot. Now, talking about human enhancement and touching what you, John, said before about the metaverse of the industrial thing, well, another type of human enhancement is augmented reality. Is augmented reality used also along with this technology with cobots? Like, it has any type of use when working with robots?
I think augmented reality can be used, for example, for remote interaction with a robot. So I think it's a modality already used. For example, if you want to demonstrate a task to the robot from remote, right, by superimposing the human hand, for example, or the human motion to a robot, and the robot to understand it via computer vision. So I think we are going to see, and vice versa, right? And vice versa. So I think we're going to see it being used. I think there is still, some way to go. For example, for augmented reality glasses, prices need to go down, and they will. We're going to need some faster networking technology to cope with more data and to give this tactile effect so that you cannot really perceive distance. And this can be done if you have a faster network like 5G, fifth generation of networking. So I think it's not a mandatory element of a cobot, the augmented reality, but there are certain use cases that you can see a cobot in the industrial metaverse. That's my take on it.
Yeah, I can add that we've seen a number of startups as well using augmented reality to teach robots, whether it's industrial or cobot, but simply using an iPad, for example, or a tablet, and recognizing the elements, recognizing the robots, and being able to teach a specific path, for example, or specific task like gluing, for example, this kind of thing, through that augmented reality interface, so that again, remove the need to program a robot even for a little bit more complex task than a pick-and-place application.
But thank you. Now, I have a quick question now, shifting a little bit from the technology part to the economic situation. So all this disruption to the supply chain, how is it impacting the use of cobots in North America, and how is it even favoring also the use of cobots in North America?
Well, I think Dean gave an answer before. There is reshoring. Now you compete with low-cost countries on labor. Now I imagine a future where this low-cost labor doesn't matter because this can be done by automation, by a robot. So that's a perfect use case for reshoring, and getting some of the production from low labor countries back to US, for example. So I think Dean gave before the answer, right? It was another question, but he took the opportunity, to talk about this reshoring thing.
True. Yeah. Well, thank you, John, and thank you, Dean. So how do you think, and this is probably a question that I would love each of you to answer, how do you see cobots being in 10 years from now? How do you see the factory floor being in 10 years from now? And I want the answer of each of you. That will be probably our final answer before we move on to the Q&A section. So I want to start with you, John. You're on the top of my image here. So.
Well, personally, I'm a tech enthusiast, so I would like to see, a shop floor comprising the most advanced of the capabilities discussed previously. Now, if I really believe that we will be there in 10 years, I would say no, because my practical experience, my pragmatic experience working with clients is that manufacturing sector is still a little bit conservative. Which is okay, of course, when it comes to IT. So I think certainly the shop floor in 10 years, it's not going to look like today's. So we will have more automation, more cobots, more cameras, more neural networks, more robotic arms. So expect to see all these. But I wouldn't say that, you will see, for example, humans in a completely supervisory role in the factory, right? Just looking some screens and commanding cobots. I don't believe that we will see this, not again because the technology is there. So technology acceleration is indeed a pragmatic phenomenon. We are living it. So technology is improving in an exponential pace, but we humans, our organizations, our companies can absorb it in a linear way. So I believe that in 10 years, things will be different, things will be much more automated, but I want to be pragmatic, and I want to say that we will still be discussing about some of the cool functionalities of today's discussion in 10 years from now. And this shouldn't surprise our audience, right? I mean, it shouldn't be a surprise for them that, in 10 years from now, they will still be listening about industrial metaverse. It takes time, it happens, but it takes time, and this is a lesson we know from the past.
Perfect. Thank you, John. What about you, Dean?
I agree with John. I think that if you're looking at it from a realistic standpoint, you're going to see more and more people moving towards technology, and we will see some companies really taking hold and really advancing the technology in manufacturing. Then there's the other end of the spectrum where there's some companies that their operations are very simplistic. I've been in plants where there really doesn't make sense for them to even automate some of the things because they're automated mechanically currently. And to get to the point of involving a cobot in it doesn't give them enough value. And that's the problem is, now I did mention earlier, and I agree, I still believe in the fact that getting people involved through it's only we're paying them per hour really is, I believe, going to get people interested, get people involved in it and say, yeah, I can see where this will fit in this application. And they can justify it, which then leads to the next question, which is, if I can justify it, I can prove my point. It's a proof of concept that you could take to the next level. And I think some of those companies are going to be pulled kicking and scratching into the future, but there's still going to be a lot of companies that 10 years from now are still doing exactly the same thing with a hammer and an anvil.
Good point. Thank you, Dean. What about you, Hayden?
Well, I think Elon Musk gave us a little bit of a preview of what he intends to bring upon us, right? So a little bit more humanoid type of interaction. Yeah. But jokes aside, I think we'll see these cobots evolve. I don't know if it's going to be 10 years or more, but we're definitely going to see them evolve more towards humanoid, like whether it's in shape or interaction. John talked about natural language processing. It's one thing to understand, it's another thing to talk, right? So we have, voice assistants today that, are pretty good, right? And getting better and better. So I think you can see the conversion of all these technologies, including AI, to make those robots a little bit more human-like in interaction, maybe in shape. Now give them legs so they can move around the manufacturing floor as well and do some tasks there. So I do believe in that future. But yeah, as Dean mentioned, there's still going to be a lot of application where you don't require that number of sophistication, maybe very simple, quote unquote, dumb cobots or even just manual labor is still going to exist. So yeah, we're going to have a pretty broad spectrum of capabilities there in the future.
Thank you, Haytham. Mohsen?
I'm going to consider this regarding the regulation standard. I believe considering the safety aspect is already addressed properly. When considering to the other type of technology, definitely there are going to be more of these into the industry as the concern for safety already addressed. Maybe the new concept is going to bring some challenges, but definitely there would be some which helps on the confidence of the population, let's say people, organization, companies, into more thinking of this, just go beyond the manufacturing to utilize cobots into the service providing. For example, organization can provide it for the receptionist. It's a cobots, as the safety aspect, interaction, and those areas addressed properly. Definitely, we are going to see, I believe in future, we are going to see beyond the manufacturing in introduction of cobots into the service area as well, considering benefit and the economical aspect of that.
Thank you, Mohsen. Well, and I think that those changes will also bring their own challenges as well. So, we are up in the time that we have for today. So thank you very much for the discussion. I know we can stay having a longer conversation here about this topic. It's a lot to talk about it, but we only had 45 minutes for our chat today. Now, let's go pass it to Matt, because there are some questions that came from our audience, and we were going to pick a few of them to answer them today. So Matt, back to you.
Thank you all so much for that great presentation. As Edgar mentioned, we are going to be moving into the question and answer session. So if you have a question for us today, please go ahead and add it to the Q&A box and hit submit. We will get to as many questions as we can today. If we do not have time for your question, please do not worry. We will reach out following today's session. Edgar, I will pass it back to you now and the group to answer some of our attendees' questions.
Thank you, Matt. We are back here in the roundtable, and there are some questions from our audience. We have selected a few of them, and we will share it with our panelists and answer them. So the first question is, which are some of the most prominent applications and use cases of cobots in manufacturing environments? Could you give some practical examples?
Yeah, sure. We covered some of that, but I would like to repeat that. So cobots are meant to work at a human level speed. So inherently, they're designed to work for processes that are not extremely fast. And mostly repetitive tasks as well. Those are kind of some of the key characteristics. So we can definitely think of a pick-up-and-place application in the assembly industry, for example. We talked about machine intending applications. Quality inspection is pretty common as well. And we see that coming as well in some other areas like palletizing. Now, it's interesting to note as well that the cobots are also started to make their way outside of the industrial domain as well. We've seen them, alongside fast food kitchen operators, right? And some of them are also making coffee as well. So the application space is expanding, but in general, it's working alongside a human is the most typical application there.
Thank you, Hayden.
Mm-hmm.
So the next question says, can you compare and contrast the human-machine interface between robots and cobots?
I could take that one, Andrew.
Thank you, Dave.
When you think about the interface itself, it used to be if you had a robot, you better be planning on hiring a programmer, because that was the rule. You had to have somebody that was technical enough and had enough experience in the programming. Everything you had to do had to be programmed. So you had to use an interface, whether it was a laptop you plugged into it, and then even the interface itself, it was all kind of like if you looked at early CNC machines, it was all just lines of coordinates. Everything that you had was just lines of coordinates, and that was the information you had. You didn't have anything else. As cobots and as robots have moved forward, the interfaces have gotten better. The cobots, I think they realized that if we're going to have people working on these and expect to manually program them, whether you're dragging them through a range of motion, whether you are trying to have them define when things are opened and when they're closed, it had to be more simplistic. So the cobots have a more user-friendly, I will say that it is much more user-friendly for the operators. And consequently, robots have been pulled in that direction too, because as cobots have evolved and the interfaces have gotten more user-friendly, robots have had to adapt some of that too. Now, don't get me wrong, robots, because of their power and their size, still have to have some hard limits programmed in, have to have some safety requirements in there. But in general, the cobots, because of their size and the motor torque and the power that they can deliver and the speeds that they're delivering them with, are much more limited. And for that reason, the motion that you're actually dragging it through can actually be controlled much easier. So in general, they're more simplistic. They are slower, so you're not having to program as much. But in general, everything there is more visual and more accessible for the operators.
Thank you, Dan. Well, the next question says, why are cobots becoming a more popular solution now?
I take this question. I think the most important item that we can consider for the benefit of the cobots is, let's see what's the advantage. And the most important one is the increasing the efficiency of the humans in working with the robots. That's the key part. There has been a claim in the study that the idle time of the human is reducing by 85% when they are collaborating in the working environment with the robot, which is fantastic from a manufacturing side. But the other hand, other viable benefits coming from, for example, the cobots can be applicable to a small or mid-sized manufacturing, which brought up some of the benefits compared to the industrial robots. For example, you can dedicate it for a small work, which you don't need to have so much capital expenditure in that case. These lower cost or lower capital required for the small size manufacturing job, it's going to show it's on the third benefit, which is coming on the economical benefit, which is shows as the rate of return or rate of investment that you're going. Normally, there are some very well known documented that with the cobots, you can get a rate of return of less than a year, which is fantastic in respect to the money that you're expending on them, for example, an industrial robot. And the other side is the flexibility that you have also when you have a cobot, because in the industrial robot, there is no interaction with the human. You just have some controls and that's it. But with the cobot, you have the option of the presence of a human. Definitely, it brings out more flexibility, which is fantastic. And somehow mentioned during the panel as well that the safety is also another aspect. Handling some of the more complex and dangerous work job, which maybe not be suitable for human or not safe for human, can be done easily without any much concern with the help of cobots. And there are some other unlimited potential considering the nature of the cobots. These are the main characteristics which shows the benefit of cobots compared to other industrial applications.
Thank you, Mohsen. Now, the next question says, what are the digital enablers of cobots?
Maybe I handle this one as a digital guy.
Thank you, John.
There are a couple of technologies that are enabling the transition to cobots, and it's actually the scaling up of this paradigm, because in the future you're not just going to have a couple of cobots in the factory, but maybe more. So I'll start with the infrastructure. So to scale the infrastructure, you will need a combination of cloud edge computing, edge of course, because some of the cobot things are happening in real time, so you want this low latency. And of course, if you have a density of cobots in the factory, you will need some upgrade in your network, maybe 5G telecommunications network and customized network for the factory. Now, that's the infrastructure part. Now, moving to the actual functionality, I think it was mentioned previously, it's all about robotics and the mechanical parts of robotics, but also different types of artificial intelligence, like machine learning, deep learning, computer vision. This is all what enables a robot to see and hear and perceive the world, and perceive also the human in the vicinity. Also, I see in the near future, we will see some more advanced artificial intelligence paradigms used in cobots, like, for example, explainable artificial intelligence. Earlier on, we talked about trust. So to develop trust and safety on the system, I need to understand how it works. So I need explainable artificial intelligence to be able to explain to the human, how does this cobot doing, the quality inspection, right? What are the rules? What are the thinking behind it? Because that's the only way for a robotic application to be accepted and trusted by the human that works around it. So certainly we will see some more advanced AI paradigm. Another one is the so-called active learning. So that's actually machine learning where when there is uncertainty, the cobot consults an authoritative source. And this authoritative source can be the human. So this means that the robot is not sure about something because it lacks proper data, it lacks proper training, but the human is beside it, and it can ask the human, it can consult the human to make sure that things get done right. Finally, it's the user interaction part and the user interface part. If you want, this was also discussed previously. So you need some ways to interact, to have the interaction between the human and the robot. And this can be different modalities, from simple dashboards to augmented reality and metaverse interfaces to natural language processing. So there are going to be certainly some of the digital technologies enabling this effective interaction. Finally, let's not forget the digital twin, because when you build a digital twin, you can allow the cobot to evaluate different options, different courses of action within a short amount of time, to evaluate different options of the digital world and perform the best one actually on the shop floor. So I see that digital twins will play certainly a role. Of course, some of these technologies will come into play when the whole paradigm of cobots scales up. Once you have just one cobot on the shop floor, things are easy. When you have starting, having tens or hundreds in the future, you need to scale up the infrastructure. You need to scale up the learning, the user interfaces.
Thank you, John. Well, time is up. Thank you, John, Dean, Haitham, and Mohsen, for sharing your time, knowledge, and experience with us and with the audience. That was an excellent discussion, and also the answers to the questions. Thank you to our audience for being here, sharing the time, sharing the questions that we answered. And we hope you can join us in the next panel of this series. And to Rockwell, thank you for doing these efforts to make smart manufacturing a reality. Finally, for globalspec.com, thank you to the millions of technical professional engineers who have allowed us to connect them with the parts and services they need for project success. Now back to you, Matt.
Thank you, Edgar. Now just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Defining the Smart Manufacturing Journey series. Today was session 2 of our 4-part series. Please join us for the rest. You can visit our series page using the link listed in the resource widget. Sign up for all of the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with us today. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. Again, thank you for taking the time to attend this Global Spec series. Take care, and we will talk with you soon.